So for this demonstration, we are going to run a crypto locker that is called TeslaCrypt. It's a ransomware piece of software that's been around for about 6 months, and most antivirus vendors should have some sort of signature built against it. Now, for that reason, what I'm going to do is I'm going to make a very, very slight modification to this file, and it's going to become now a new or never found form of malware in the eyes of our antivirus vendors that happen to be out there. So I have my TeslaCrypt here. I'm going to move it over to my desktop. I'm going to make this an executable. And then I'm going to do the slight modification on that. So let's open up the command prompt here. And from here, we're going to change to the desktop. And we're going to echo in flowers, because flowers have never hurt anyone. So we're going to echo in flowers. We're going to put in our file name. And so what I have done is made a very simple change. I just added flowers to the end of our TeslaCrypt file. Now what that's done is it's changed the hash. So as far as any antivirus out there, we're not going to know that this isn't a crypto locker or a malicious file at all. Now before I run this, I'm going to go over here to my pictures so you can actually see when the encryption is taking place. And just a brief overview of what's going to happen is I'm going to open the file. It's going to delete itself. It's going to create some restore files, which are going to then pop up and say, if you would like to unencrypt your files, this is what you have to do. And you're going to see these pictures right here all get encrypted. So without further ado, let's go ahead and run our virus. So you can see the file's been deleted off the desktop. Sentinel-1 has detected our threat, so we can see that we are infected with something. And now you can see our pictures have also been encrypted. So the last step is going to be a pop-up letting us know that our machine has been fully encrypted. So here you can see our pop-ups coming up. This is going to tell us our machine has been encrypted, what happened to our files. They've been encrypted with the RSA 2048 encryption level. And it tells you what it means, which means that your files have been changed. You will not be able to access them. How did it happen? And then, of course, what do you do? And this is where they say, follow these websites and give us money. And it's usually in the form of Bitcoins, which is extremely difficult to do if you have no idea what that is. So we're going to close these. And we're going to use this analyze to see exactly what has happened. So here you can see TeslaCrypt 2.0 was run. On the machine it was run on, I click on it. This brings me right to the binary analysis of our threat that has come in. We can see the file name is the TeslaCrypt, where it was directly on the machine it was on, when it was identified. And we can even see here, it's only been seen one time on the network. Now, this is again because I made a very slight change to that file. I added flowers to it, and it completely changed the hash, and now it's a brand new, never before seen malware. Same thing for our cloud validation. That's why we don't have any matches, because at this point, it's a brand new file. Now down here we can also see some of the other information. The network connections, this is going to allow us to see where the attack happened and where it's trying to reach out to, so you can see some of the other marks up here. We have our attack overview, which allows us to see all the files that were edited in some way, either deleted or created, what was used on the network, how many events happened on the network, registry changes, processes that were used, and then of course a total of everything. We even see on the left here our severity, showing us like network activity, and then general stealthiness, all that stuff. We can see all that right here. Now, this is very, very good information because this is going to accelerate your incident response. So it's a very big like call to action. Something's happened. We need to take a look at it. Now, one of the coolest things that we have is our attack storyline. Now, the attack storyline allows us to see every step of the process that Tesla Crypt took in this case. Now, when you see this storyline, the only reason we're seeing all of this is because we were in alert mode and we allowed this virus to run. If we were in kill or quarantine, what would happen is we'd still see the storyline, but it wouldn't have been able to spread this far. Now, what we can do is we can click on these. So we can click on each step of these. We can see the process ID that was used, and if there happen to be any events that were used during that particular process. So we'll just go ahead and we'll go over here to step 3. This is where our Tesla Crypt really starts to run. And we can go under our events and we can see here we've deleted ourselves. And then we can also see we've created some new files. Now, creating an executable when a file shouldn't, that's, of course, a description of malware. We can see writing to files, files that were copied, and then we even have our other, which allows us to see when root process creation, that shouldn't have happened, and then our additional processes here letting us know that Tesla Crypt has created some new processes and the processes that were affected. If we go up here to this step 5, I know I'm skipping over some steps, but this is the big one. You can see all the traffic in and out of this particular process. Your details allow you to see the hash, and then the events. Our events here, you can see all the files that were written or changed. We have our network, all the different places it tried to go. We have the processes that were affected. So here we're trying to harvest window credentials. And then lastly, we can even see the registry keys that were created. And in this case, these are auto run keys. So this means it's going to try to run every time the machine is started. Now, we have our machine has been encrypted. We've identified it as Tesla Crypt. So how do we fix this problem? Well, we can do it from a couple different places. We can do it right here. We're already in the analyze. We have it open. We go over to our more. And we can see here we can kill the process. We can mark it as resolved, disconnect it, or quarantine it. Unfortunately, these things aren't going to really work for us because the machine's already been infected. But we can go down here to rollback, and rollback will allow us to prevent this attack like it never happened. So we'll be able to roll back the machine to before this attack happened. You can also go to your activity, and from here we can click on the drop down, go to our actions, and this will allow us to roll it back. Now, I'm going to roll back this machine, but I want to show you guys we have our files on the desktop. We have our pictures here. They're still all encrypted. So let me go down to our actions. I apologize. Let me make this just a little bit bigger for you. And we're going to then roll back. So the command has been given to roll back. And you'll see here the files on the desktop will disappear, and we'll also see our files. You can see they're already disappearing, and our pictures are going to come back, and it'll be like the attack never happened.